In this topic, we're going to continue our discussion about operations on radicals, but now we're going to start mixing our operations. Okay, so for example, in this topic, we want to look at how we might simplify something like root 2 times the sum root 5 plus 3 root 2. And there's actually hopefully some intuition here. If you multiply anything by a sum, you know that you're going to have to distribute. Okay, that's how multiplication mixes with addition. So in general, our radicals are going to follow the same sort of rules that our integers follow. So let's go ahead and look at specifically how we can work with such expressions. So the easiest way to keep your operations on radicals straight, I think, is to treat the radical expressions like polynomials. Okay, whatever you can do to a polynomial, you can do to a radical expression. So for example, to add or subtract polynomials, you collect like terms. It's the same for radicals. To add or subtract radicals, you collect like radicals. Moving on, to multiply or divide monomials, so remember monomials are one-term polynomials, well, you would use your product or quotient rule for exponents. 3x to the 5th times 10x to the 4th would become 30x to the 9th, right? You add the exponents on the x and you multiply the 3 and the 10. It's a similar rule for radicals. Right? To multiply single radicals, use the product or quotient rule for radicals. For example, 3 fourth roots of 15 times 10 fourth roots of 5, you're going to go ahead and multiply these coefficients just like you would with polynomials to get 30. And then you're going to use your product rule for radicals to multiply the fourth root of 15 times the fourth root of 5, which gives you the fourth root of 15 times 5, right? Remember, you can multiply underneath. And then altogether, that's the fourth root of 75. Okay, so just like you do with polynomials, multiply the coefficients and then multiply the radicals using the product rule. So we can continue our analogy to help us understand how our operations mix. Right? So for example, to multiply polynomials, right, multiplying polynomials mixes multiplication with addition. To multiply polynomials, you would either distribute or FOIL, depending on how big the polynomials are. Right, in this case, we just have to distribute the 3x squared. It's the same idea when you're dealing with radicals. To multiply sums of radicals, you either distribute or FOIL. For example, if you had 3 root 15 times 4 root 5 plus 3, you would have to distribute this guy to each term inside the parentheses. Once you distribute it, you get 3 root 15 times 4 root 5 plus 3 root 15 times 3. Then you multiply the coefficients to get the 12 here, and you multiply the radicals to get the root 75 here. Same thing on the second term. The 3 and the 3 are both coefficients, so they would be multiplied to give you 9, and the root 15 stays. So the main idea for this topic just repeats what I've said to you probably 5 times now. To perform mixed operations on radicals, treat the radical expressions like polynomials. Okay? Or if that didn't make sense, then just follow the instructions that I gave in remark 2. Okay? Now let's just jump right into some examples and see if we can deal with these mixed operation problems. So here's our first example. We have the square root of 2, and we're supposed to multiply that by root 32 minus root 10. When you have a single square root being multiplied by a difference or a sum of square roots, the idea is to distribute. So this product is going to become root 2 times root 32. Right, when you distribute the root 2 to the root 32, you get this, minus, then you get root 2 times root 10. At this point, we have a single radical times a single radical. So here we can multiply underneath the square root symbol. That's what the product rule tells us. So 2 times 32 is 64. Again, we have a single radical times a single radical. So we can multiply underneath the square root symbol, which tells us that we should have a square root of 20, since 2 times 10 is 20. Okay, now we've done our multiplication, but we have to simplify each of these radicals so that we can see if they're like radicals and then collect them if we need to. So 64 is actually straightforward to simplify since it's 8 times 8. 64 is a perfect square. Root 20, in order to simplify that guy, we got to factor down 20 into 4 and 5, factor the 4 down, a 2 and 2. So there's going to be a 2 outside, and then a 5 inside. So altogether, instead of square root of 64, I'm going to write 8 minus, instead of square root of 20, I have 2 root 5. 2 outside, 5 inside. So that is the simplified result of this multiplication. So for part B, we have slightly more complicated radical expressions to multiply. Right? We have 4 root 3 plus 3 times root 5 minus 2. So because of this plus and because of this minus, we're actually multiplying binomials. Okay, we're multiplying a sum of radicals with a difference of radicals. So the strategy in this case is to FOIL. So we're going to multiply the first terms, the outer terms, the inner terms, and the last terms. Okay. So when you multiply the first terms, you take 4 root 3 times root 5. So let me write that. 4 root 3 times root 5. The outer term is going to give me a 4 root 3 times a negative 2. So minus 4 root 3 times 2. The inner term is a 3 times a root 5. So plus 3 times root 5. And then the last terms are going to give me 3 times negative 2. So minus, I'll just write it for now. Okay. At this point, we've expanded out our product here, but we still have more multiplication to do. Okay, so for example, 4 root 3 times root 5, we can multiply underneath the radical symbols and turn this into 4 root 15 minus 4 root 3 times 2. Here we can multiply the coefficients, 4 and 2, to get 8 root 3. Plus, well, 3 root 5, there's nothing I can do with. There's nothing that can get multiplied any further. And then 3 times 2 is 6. So now we've performed all of our multiplications. The only thing left to do would be to simplify. Okay, but 15 is 5 times 3. There's no pairs, so the root 15 doesn't simplify. Actually, none of these square roots simplify. So this is our final answer.